Good afternoon, everyone. For our next presentation, I'd like to present Pouya Ghotbi from AWS, talking about advanced threat hunting in the cloud. Please make him feel welcome.
Thank you. Thanks, Billy. Can you guys hear me okay? Yeah, I can hear myself, so all good. I know I'm holding you up before lunch, so I'll try to be quick and interesting, hopefully. So as Billy said, my name is Pouya. I'm the security lead for professional services in AWS. So my day job, I work with public sector of Australia and New Zealand, trying to help them with their cloud journey from a security point of view. And one of the things that I noticed working with our customers is when it comes to detection and when it comes to threat hunting, the level of maturity across the industry is in cloud is quite low. And one of the reasons for that is the fact that we don't necessarily know the differences between threat hunting in cloud and on-premises, how things have changed. So hence, I came up with this presentation just to walk you through, and what we're going to do, walk you through some of the foundations of, very brief foundation of threat hunting. Then we look at building a framework, and then I'll walk you through a real-life example of a threat and how would it fit in this framework. Just a refresher on threat hunting. So essentially, we've got some raw telemetry. So you've got logs, you've got a lot of telemetry that comes from different sources. We typically take two approaches. One approach is we apply analytics on top of those, and then we've got some detection. So some events, we detect those events, and then it's going to generate alerts. Then we go through triage, and then we investigate it, and then we respond to that. The other approach that might be a little bit more proactive is our threat hunting. And that could be if you've got any predefined queries. There's certain things in our environment that we know we're looking for and we're hunting for, and then we get alerts around that. Or there might be some threat intelligence. So we know that, let's say, I don't know, I'm in the energy sector, and then there's a threat out there, like threat actor has been after other energy sector organizations. I know they might be coming after me. So I've got that threat intel. I just want to go and search and see if that threat exists in my environment. And we always assume breach. So we assume that the threat actor is there. We're just looking for evidence. Because as much as we love our security tools, attackers obviously can bypass those tools. And then when we get that intelligence, or when we've got alerts on our queries and automation that we've got in place, then we've got some leads. And then we're going to go and investigate those leads. So eventually, everything comes together. So we're going to investigate. We want to understand. We want to contextualize it. We want to make sure that what we're seeing is actually correct and it's true, and the threat is there. And then we go through the incident response process. So the focus, what we're talking about today is the red part, the proactive part, setting up those queries and automation, and then integrating threat intelligence into that. So I initially said, like, cloud is different, but how is it different? So obviously, there are many benefits of cloud, right? Agility, time to market, it's just fast, like we can just go crazy, can create resources. But with that comes another side of the challenge when it comes to security, because we have resources that are being created, but a lot of different teams within our organizations, we don't necessarily know who they are, when did they create that. So there might be business unit, they're running their own product, and they create resources. And when it comes to security, specifically to threat hunting, there's a lot of data that we need to ingest, we need to process, and we need to make sense of it. So we need to have information out of that data. So there is a lot of things that we need to consider. Scale is super, super important, because when we move into cloud, then obviously we're moving faster and we're moving at scale. So our security controls security tooling and processes should scale as well. And that includes threat hunting. And obviously, we need to be proactive because with the rate that we're developing in cloud, if we are not proactive, or we're sitting back relying on the detection tools only, we're going to miss out. And this has been proven. Like, there's so many breaches out there that have, bypassed the security controls. But if I want to build a custom framework, there's some key components that I need to build into this framework. I need to have a source of telemetry. And in cloud, one of the benefits of cloud is that's very easy to get and centralized. So I'm going to consolidate all of this stuff. And we will talk about how to do that. I want to have a detection logic. And that logic, these are the rules that we want to build. And then I want to enrich the context. I want to add context to that. Because if you look at the, if you look at our detection logic, for example, we can't search for everything. We can't detect everything. So we need to look at what makes sense in our environment and in our context of our business. And obviously, after that is going to be response. And response automation in cloud becomes important because we're automating everything else. Everything is code. Our infrastructure is code. And we do have that automation in place. Therefore, our response should match that as well. So considering those components, came up with this framework. So essentially, we've got inputs. And this is the telemetry that we're getting from our cloud. And you're going to see I've got references to AWS because obviously I work for AWS, but this is generic. It's cloud agnostic. So it applies to all cloud providers. You have threat intelligence feed that you're going to use, and then context. And that business context, industry context, that's very important. What are your crown jewels? What are you actually looking for? What attackers are potentially after coming to your organization? Then we've got the detection layer. And this is where we've got our rules, we've got our baselines, and this is where we use everyone's favorite Gen AI just to help us, make sense of all this stuff that we've got, and we'll dive deeper. Then we want to correlate everything together. So we've detected, we want to make sure that this is actually correct, and if you've got different sources, we've got that normalization and correlation, especially if you're multi-cloud. Then we want to make sense of it and have insights. Then there's going to be the automation for alerting and response. And the most important one that's typically forgotten is the feedback loop. Because, and this is common, I've got friends in the audience that they're incident responder, and they know, like, we detect something, and if you don't loop it back, and you don't learn from it, and you don't tune and refine, it's going to happen again. All right, so let's have a look at the first four, starting with the inputs layer. So we've got the cloud telemetry. So the examples that I've got is from AWS. So we've got CloudTrail, for those of you that are not familiar. So everything in AWS platform is an API call. And then every single API call is recorded. There's a log, tamper-proof log of that. And this becomes super, super important because every single activity is logged and is stored in this service called CloudTrail. You may have VPC flow logs, which is just net flow, essentially, because you want to know what the network traffic is. You may have some application logs that may be relevant in the context of what you're hunting, and configuration of services. Because one of the things that is interesting in cloud, the vulnerabilities are not necessarily from infrastructure. A lot of the times with cloud services, you've got the abstract service, the infrastructure is managed by the cloud provider, but what can get you in trouble is misconfiguring that service. So that configuration of the service is also an attack surface, and it's actually quite an important one. If you've got any containers or serverless logs, they're also there. And again, this is growing more and more. Serverless, this misconception that, all right, it's serverless, we don't need to secure, or there's minimal things that we need to secure, but they're actually a big attack surface these days. Then we've got the threat intelligence. sort of thing. So we've got the indicators of compromise. So we've got sort of tactical threat intel. We may have some operational threat intel. We know who's targeting us. I was talking about the context. Obviously, one of that context is threat intelligence. Who's attacking us? If you've got tools that they do, I don't know, deep dark web monitoring, for example, you know there might be certain threats out there. There might be an initial access already in the organization. So all of that is important, and you want to go and hunt for it. So actor profiles, what we're facing these days, there's a lot of state actors in Australia attacking us, targeting us. So, and every industry sector is also different. They've got their own threat actors. So knowing their profiles and what tools and techniques they're going to use, that's also very important. And we'll see in the example, we sort of map it. And the business context, as I mentioned, like what's important for us, what's in it for the attacker to attack us. So all of that is the input that we want just to build the foundation. And then we're going to start hunting from this point onwards. In the detection layer, there are different ways of doing the detection. So obviously, a lot of, like, in AWS, we've got guard duty, which is a threat detection service, but you may have other industry tools for detection. But what I'm talking about is not just that base detection that's provided by the cloud provider or by the tools. It's just adding some extra custom things on top, custom detection on top, specifically targeted for what you're hunting for. And that's the whole point of threat hunting, right? And this can be any sort of query language that if you're using Splunk, Sigma is another one that we use in AWS. So what's important is because everything is code, our infrastructure is code. We're doing things in a DevOpsy way. So we've got CI/CD. Our detection should also be code, and it should be versioned and run in CI/CD, because then only you can keep up with the pace in cloud. So that's quite an important thing. From an anomaly detection, you've got a couple of options. And this is obviously a framework. This is generic. For each of those, you may already be using a tool, and that's perfect. You may want to get the output of the tool, or you want to build some custom sort of anomaly detection. Like you may have an ML model built around your logs in your context and doing that in baseline creation and anomaly detection as well. And the Gen AI part, this is just one, sort of two use cases that I mentioned here, but the possibilities are endless, right? All you want to do, because you're dealing with a lot of data, is a lot of telemetry data that you're dealing with, and you want to make sense of it. You may want to map it, or you may even want to just understand what's going on, because it's just so hard. Like you can't really go manually and make sense of it, right? So Gen AI is really, really helpful here. One of the interesting so you've got obviously different options. You can use the public models. But typically these days, I don't think any organization would let you just go public and you upload the data and see what happens. And everyone's going to learn from your data. If you've got your own model, so the model that I personally quite like, and we did this for a couple of customers, was having a model, you take the base model, but then you've got your own model that you basically, it learns your environment, and then it's context aware of what's happening in your environment. So it's customized for your need. And obviously your very important threat data is not, or security controls data or whatever, it's not shared with the world. So the two sort of use cases, like natural language queries, overlogs, what am I looking for? Can you find anything like this? And again, a lot of security tools already have those capabilities built in. And then hypothesis generation, so that's part of the threat hunting as well. I just want to know, is it possible, or I'm looking for this particular thing. What should I look for? What query do you suggest? So all of that is part of the Gen AI assistance. So we've got our inputs, we do our detection, but now we need to bring everything together and correlate it. So telemetry normalization, especially if you're multi-cloud, I'm going to say multi-cloud, there's also on-prem as well. A lot of activities, although we say cloud, but a lot of our systems are still on-prem. A lot of the times, even our identity stores are on-prem for a lot of, at least public sector organizations that I'm dealing with. The domain controls are on-prem in a secure sort of zone in the network. But you need to get those logs as well. So multi-cloud plus on-prem, I should have added this here. But then, because they're all coming with different sort of formats, you want to normalize it so you can make sense of it. So cross-correlation, this is the part that is also, because you're building something custom on top of the correlation that the basic tools are doing for you. So you want to know, like, for example, one of the biggest differences in cloud is identity. We used to say is the new perimeter, but it's essentially, it is the new perimeter, but it's essentially the biggest attack surface that we've got these days in cloud, because a misconfiguration of identity or a credential that is exposed, your environment can be easily accessed, and we'll see in the example that we've got. Linking that identity to the actions in our hunting, that correlation, and identity might be across different cloud providers and different systems as well. So how do you correlate it? Is the Pouya that you see in AWS is the same Pouya that you see in Azure or in GCP or on-prem? Correlating all of those, because you've normalized. Now I'm going to link this identity to all of this telemetry data that I've got. And then you may also want to do some mapping. And a lot of SOCs do this, like they use, for example, MITRE ATT&CK, and you want to map it to MITRE ATT&CK just to make sense of it and normalize it, and then your response is going to be easier. Because by the time, remember, we get to the response layer in the automation, so your responders, if they know what are the TTPs that they're dealing with, and having a mapping to MITRE ATT&CK makes life easier. So doing that alignment here in the correlation engine is important. And obviously, reconstruction the timeline as well, like what happened? What's the sequence of events that happened to make sense of the threats? So we've got our inputs, we detected, we correlated. Now we're sort of going through the response phase. And that's when automation is quite important. So you may want to have some event-driven triggers. So I've got my rule, I've detected something, so what? What can I do with it? I need to let the responders know, so I'm going to need some automation in terms of sending alerts and notifications. And there are examples in Azure, GCP, and AWS that you can use different services to do that, as well as for notification. If you do have a SOAR solution and you want to use that SOAR solution, this is where you integrate to SOAR, and then you let SOAR do the rest of the job as part of the workflows. The automated workflows, there's certain things that you want to do because you don't necessarily want to take action at this point. All you're doing here, you're just alerting, and then you're triggering, you're starting a workflow. In cloud, a lot of times, those actions might be tagging something. You just tag something, and then with attribute-based access control or detection, you deal with it later on at some point. So there might be a tagging, might be adding some or enrichment of data, like in your detection, you come across a virtual machine or an EC2 instance for us that is potentially compromised, and you've seen that threat in that machine. You add a tag, you add some information to that, so then later on in another dashboard, in another process, you can pick it up. If there's something like it's like an access key, which is a type of credential you've got, and you realize that that credential is compromised, you're not going to tag it and wait for it to resolve later. That's where you want to take action. So you can sort of block those access keys or disable them, or if there's an instance that you already know for sure, or with a sort of high degree of confidence that you know that host is compromised, you want to isolate it. You want to contain it. So some of the things, the really important ones, you do that, and then in the response process, you just follow. Some of them, you just enrich the data and tag and then move on. And obviously, you want to notify the teams. And this can be a ticket, it might be Slack message, it might be a Teams message, whatever notification method team uses. So let's walk through, this is hypothetical, right? So this is an advanced persistent threat, or there's APT29, it's also called Cozy Bear. They're really known for a lot of cloud attacks and around identity. So compromising identity or compromising a machine, and then they find identities to get access to cloud on the user's machine. And then we just want to say hypothetically, in this case, let's say they had a phishing campaign, they caught one of the developers of the organization, got access to the machine, and then they had the access keys of AWS, hard-coded somewhere in the configuration, and then they use that, and then obviously, cloud being accessible, they can use those credentials to get access to AWS. And then from there, it's going to be just a normal attack, like escalating privileges. What roles can I assume, for example? Is there anything like, as a developer, or maybe have very restricted, my initial role might be very restricted, but then I can assume a role and become an admin, for example, temporarily. What are the things that I can do? And then what sort of data I've got access to that I can exfiltrate out of the environment? So let's see what this, going through this framework, how would that look like, hypothetically? So you've got some telemetry sources. I did talk about CloudTrail. So from the first moment the credential is used to get access to AWS environment, that is logged in CloudTrail. So you can query CloudTrail. You can see if this identity is used credentials to log in. You can see where that login happened from. So you've got geolocation data. You've got the IP addresses. And there might be some, like if they're a threat actor and they're coming from a known bad IP address, a guard duty service may already detect it and say, oh, there's this connectivity from this known malicious IP address. That is an input for us as well. So we're just working on top of that. From threat intelligence, we know the ranges that Cozy Bear uses. So that's coming from feed. It may already just because this is a bit confusing. So our guard duty service, for example, we've got our own threat intelligence feed, and from industry that we feed into guard duty. So that exists there. But sometimes you want to subscribe to another feed, or you want to have extra threat intelligence added to your process. And then you may have the IP addresses there, and then you know that this STS abuse that I've used here is a technical term, which is essentially temporarily getting credentials to do something. So you get a temporary credential, a short time based credential to do something. So when you assume a role, when you assume another sort of set of privileges, temporarily you're going to have a set of credentials that will be used to perform those actions. And we know that Cozy Bear uses those. So they try to see what roles they can assume. Sometimes the roles that are attached to resources, for example, EC2 instances may have roles to do certain things as a machine identity. They may be able to abuse those roles as well. And then we've got IOCs that match what we found about communicating to the command and control infrastructure of Cozy Bear, just to exfiltrate data. And the business context here for us is, so this user that was flagged dormant, like this user probably left the organization even, this developer, long time ago, but they still had the credential somewhere in code, or maybe hard-coded, like on their personal machine. We know developers and how they work. The easiest way to get the job done, right? And that's typically where things go wrong. But we know this user has been dormant or hasn't been used. So that's very important in the context of hunting for us. So we take all of these inputs. And then we may have, I said, a Sigma rule, but it might be Splunk rule, whatever code. And what are we looking for? So the first thing that the attack is probably done when they got access, because they want to have persistence. Maybe this credential is going to be disabled by an automated process tomorrow. So the first thing they want to do, they want to create another access key just to create persistence. So now I've got my own key to the kingdom. And then it's attached a new policy. So essentially, it's given itself permissions to do certain things. So we want to look at those. We want to look at the geolocation as well. So this is going to be our policy. This is going to be our detection. And then there might be an anomaly. And this anomaly can be through different ways. So cloud services may do that, already tell you that, hang on, this user never logged in from this location. Or you may have other security services that do that as well. They've never logged in from this location. And one of the things that Guard Duty picks up is they've never done these particular actions. So they've been a developer. They've only used these services for the past so many months, right? All of a sudden, they got interested into Gen AI, and they started doing things that is abnormal for them. So with the Gen AI augmentation that we were talking about, you can just say, like a query, like summarize all the CloudTrail actions by this particular user in the last 24 hours, right? And it will generate the query for us, stick it in, and then we find all the actions. And those actions become very important in our correlation later on. So just an example, this is a Splunk rule, a Splunk query essentially. So what we're looking here, we just said, just give me all the create access ones, and then you can optionally add time frame as well. You can just say in the last 24 hours, every single access key creation, show me. But that's not enough because you may have a lot of legitimate access key creation. So you're going to have another query that says, show me all the dormant users in the last 30 days. If you've got a user that has not been used, and I'm sure you've seen it, like we're very good at onboarding and creating users, we never clean them up and offboard them. So the lifecycle management of long-term credentials and long-term users, it's always a challenge. So I want to look at the users that have been dormant in the last 30 days. So there are two separate queries. But what I can do, I can just combine them together, join them, and this is going to be one query. So what I'm saying now, show me the users, or show me the access key creation activities of users that have been dormant in the past 30 days. Right? This is a very simple rule, but they can get really complex very quickly when you're hunting for a complex threat. But this becomes a code, and this can run, and you can run it in the pipeline, or and when we say detection as code, that's what I'm talking about. And this can be any sort of code. All right, so we detected. Now we want to correlate it. So first of all, if there are any API calls, as I mentioned, like CloudTrail captures all of those API calls, is there any pattern for that identity access? So if that identity is being used for the past couple of months from within Australia, never been used outside of Australia, and then all of a sudden it's been used from Russia, so there's obviously a pattern that doesn't match. The other thing that is quite important is the data movement logs. So this user traditionally never copied data from an S3 bucket. So S3 bucket is just a data storage service for us. And they've never copied data because they never had to. Code was supposed to do that, right? Application was supposed to write to this bucket, read from this bucket, but all of a sudden this identity is now copying data from that S3 bucket. And remind you, copying data is an API call, right? So it's captured. So I can now see that data has been moved by a user that's never done that. And then there's a sequence of events that I want to see. I want to see an access key being created, a policy has been attached, then a role has been assumed, so I've now escalated my privileges, and then I've started looking at the files in S3 buckets and then copying them across. So that's the sequence. And you know what? Like if I look at the TTPs for this attack, threat actor, I can see it matches these three tactics that they've used. They have valid accounts to get access to the environment. Usually, when they're in, they've got valid accounts. They manipulate the account by creating a new credential for persistence that matches. And then they typically steal data. So they copy data out and exfiltrate it. Obviously, this is a very simplified example. In a real life scenario, it might be many more tactics and tools and that they use, but it matches. So we probably have a match. All right, so now we think there's something in this. So now we want to trigger a response. So it might be the first thing we want to do, we want to disable those access keys to break that persistence so they don't have access. Then we want to notify stock. It might be like a notification that we send, Slack message, a ticket, whatever. And then what we want to do, because we want to, the whole purpose of this is we don't want our responders to go back and query and search all of this again. So what we do, we take the telemetry that we've got related to this case, we take a copy of it or a snapshot and then attach it to the ticket or just put it somewhere for them to have a look. And if you've got a SOAR, optionally we can integrate with that workflow, right? We can just say, you know what, Mr. SOAR, you want to go and remediate this? This is all I know, and these are the things that you need to do. So we just integrate it into the workflow. We also want to make sure that if there is a playbook already in place for data exfiltration, we can trigger that as well. Because a lot of times we've got playbooks, we don't trigger them. They're just sitting there nice in our Confluence pages, but they're not triggered. So we want to make sure that is triggered with the mechanism that we've identified. So we did all of that. We sort of take an action. We stopped what we could do by disabling the credentials, and then we send notifications. But what we want to do now, we want to do some tuning and refinement. And that tuning might be, post-incident reports. Again, our friend Gen AI is going to help us do the hard work for us and write our incident report. And then we can just tag, like this is a true positive, it's an external actor, that is the actor. We just add all of that information to our incident report. From a refinement point of view, we'll say, all right, maybe I actually didn't look at attached user policy before. I just looked at the access key creation, if you remember from my query. Maybe I'll add this in because that's part of the pattern. That's what makes it work, right? So I'm going to go back and I'm going to refine my code. It's going to be a new version of code. We committed to the repo, and as well as assuming role. Now my detection is more accurate. So I've tuned it. So what we talked about was the fact that threat hunting in cloud is a little bit different because we're dealing with a lot of data. There is more complexity. We've got a new attack vector, which is identity, which can be deadly. Just expose credentials, access keys on someone in a code somewhere or someone's computer. It can end up to like a full compromise and data exfiltration. And we walked through the framework that you had the inputs, you had detection, you had correlation, and then what else we had? Should have forgot. Automation and feedback, right? But what are the three things that I want you to take with you? First of all, when we're dealing with cloud, and this is a generic statement when it comes to security, we just need to approach it differently. We need to have a new mindset. We need to think about it in a cloud way. We need to think about scale. We need to think about accessibility. What are the misconfiguration? So the new attack surfaces and new attack vectors. And when it comes to threat hunting, we obviously have to take this in and incorporate it in our threat hunting. Having a framework, it really helps because then you've got a structured way of doing things, and then you can refine it, and you can add tools, remove tools, because tools change over time, and every time you may have you may start with using cloud native tools, but then part of the framework, you want to replace it with an industry tool, for example, or vice versa. We see it all the time, both ways. And using Gen AI just to make it simple and easy, but my recommendation is using it, like hosting the model or having a private instance of it, definitely not using public, because then all of your thread data is going to be out there as well. That's about it for me. Any questions?
Questions? Yes.
Of those 5 steps in your threat hunting framework, which do you find is the most difficult for organizations to get a handle on?
Most difficult too. So out of those 5, the most difficult one I think is, in my experience, is correlation. Detection is, so with cloud specifically, having inputs is very easy. You can just centralize logs very easily. You can have policies that says, all the logs should come to this bucket, and then I can just query that bucket. You know, all of that stuff is easy, relatively, if done correctly. Detection is also relatively easy. There's a lot of knowledge. We can also use Gen AI just to, create those rules for us. But correlation is where the challenge is, because your telemetry, like let's say you're implementing this on AWS, for argument's sake, and then you've got telemetry from Azure. So you need to bring that telemetry in. You need to normalize it. So you need to understand the structure of different telemetry. You need to come up with a normalized version that works for you, and then correlate this all together. You need to store it somewhere. There's a lot of work in the correlation part. And I'll sort of walk through, I'll sort of pass through that very quickly, but that's actually where you typically get stuck. But one approach that I always suggest with anything security, but especially in this case, is starting small and then repeating and expanding. So if I'm multi-cloud, I would start with my most dominant cloud provider, like the one that I've got the most resources in. I just do a single cloud, but I do it right. Then I start expanding to other cloud providers. Cheers.
Were there any other questions?
Amazing. Let's go for lunch.
Excellent. Could you please thank Pouya?
Thanks so much. Cheers.